Hello, everybody, and welcome to today's vOLTHA TST meeting. Thanks for joining. As usual, the call is public and recorded and will be shared live on YouTube. So please be mindful of the comments you make and information you share. They will be publicly available. So today, I just want to start with just an update. I hope David would be here, but he's not here. On the reconciling, maybe Ken, do you know what's the status of this?
Yes, it's actually David is away today. It's out of the office, PTO.
Oh, okay.
Yeah. So Maninder's working on the patch. So we had a meeting with him last week to look at his proposal. So we find that there's some major rework that needed there, and so he's working on that. So hopefully we'll have a new patch, updated patch this week.
Okay, sounds good. Thanks. If anything is needed from our side to test this or anything else, just let us know. Be happy to help.
Yeah, thanks.
Okay, awesome. Then from myself, there's a little bit of an update on the bandwidth profile. The patches for the MEF and ITF definitions have been merged. Thus, we support both definitions on the northbound of ONOS, and we support all the 5 TCON types. Thanks a lot to Netsia for contributing this feature. This is much appreciated. It's present on master, and the tests have been also updated. So that's really good. On the multi-uni support, I don't expect there to be any major update. I know the work is ongoing, but maybe Mahir, you know a little bit more about this?
Yeah, as you said, the work is ongoing. I upstreamed a draft patch to OpenONO Adapter Go, and the next ones are on their way. So we're working on, but they need a lot of tests, so they will take some time.
Okay.
Özge is also working on a patch, and Onur is working on ONOS application sides. So next or the second week, 2 weeks later, we can have some patches upstreamed.
Is it this one, Mahir?
Yeah.
Okay. I'll try and take a look at this one myself.
Mm-hmm. It's in work in progress patch because the discussion on the Slack, Holger and Michael wanted to see the patch and to discuss one. So this is still on work in progress patch. Okay, I'm testing it.
Okay. Good. Okay, thanks. It's good to know. Now, the real topic that I wanted to discuss with everybody today was a huge work that Girish has done on the document that we started around the storage considerations. In particular, he did some case study on what we are storing, how much we are storing, and can this be changed or reshaped in a lesser format or not stored at all. And so he did this amazing work. And Girish, do you want to share the screen yourself to go through the document, or you want me to keep up the sharing while you talk through it?
Yeah, I can share it.
Okay, then I'll let you share.
I hope you can see the screen. Let me know when you can see.
Yeah, we can see it.
Okay, so this is the study on the type of data stored on etcd. First of all, thanks to Ken as well. He helped me update the rewrite code part of the data. Yeah, so the scope of the study was threefold. First was to study what is the data that we store on HCD. And the second was to really analyze if we really need to store this data on the HCD. And if you need to store the data on HCD, does it require strong consistency or eventual consistency? So the version of the software used for the study was, it's mentioned here, the commit versions are mentioned here. These versions are slightly older than the vOLTHA 2.7 release, but nothing has changed in terms of the data that we store on HCD from then to now. So the study is still good. Yeah, these are the categories of data that we store on HCD. First is the templates, which includes the MIB and tech profile. Then there is read-write core persisted information, which includes devices, logical devices, flows, logical flows, ports, and such. And then there is adapter information as well as device type per adapter information. The OpenVOLTHA adapter persisted information consists of various internal resource mappings, mostly on a per PON ONU unit tuple basis, which is required for functioning of the OpenVOLTHA adapter for managing the OLT and the ONU devices. Then there is OpenONU adapter persisted information. It basically persists the ONU persistent data structure, which consists of various stateful data like the MIB state, TP-ID, and VLAN information. It also persists the L2 PMs that are active, pending delete, and pending add. And the last one is the resource manager. It persists the PON resource pool, which is basically the gem port, alloc ID, and ONU ID per PON port. I have not mentioned here, but it also persists the TP instance, which is basically an instance of the TP template. So as you will see here, some of these are fixed size, like the templates and resource pools. I mean, these are created at system startup, and so I mean their size is fixed, but the size of the other data varies based on the number of services, number of ONU devices, flows, ports, etc. Okay, now coming to some of the low-level detail. Any questions so far? Okay. Interrupt me whenever you have any questions. So the next one is, so now let's go to the low-level details of each of the categories of data that I just discussed. The first item here is the templates, which is the MIB and tech profile, and template instances like the tech profile instance. The ONU MIB template key consists of the ONU vendor model and the software version. The value is of course the MIB template. The format is JSON and the size depends on the ONU model that you're using. I have seen it's about 75 kilobytes of data for the alpha ONU model that we use in the lab. Again, the size could vary based on the model that you use. Can this information be built on K8 port restart? Yes, you could build this. I mean, on restart, you could do a MIB upload procedure again, and then you could build the MIB template, but you really don't want to do this. It's a costly operation. There are hundreds of MIBs that you would want to exchange, upload from the ONU. This information is usually keyed in by the operator at system startup, and there is no necessity to do a MIB upload every time the adapter restarts. And it doesn't really require strong consistency because this information is keyed in at system startup before any ONU or subscribers are provisioned. So eventual consistency is good enough for this. For a similar reason, the technology profile template as well, does not require a strong consistency because this information is keyed at system startup. But this information cannot be rebuilt on pod restart, I mean, this information has to be there on the etcd store or any DB that you use, and has to be keyed in by the operator. The typical size that I have seen, I mean, I have, I forgot to mention that I did my tests with one OLT, one ONU with AT&T workflow, and the study is based on that. And the typical size I have seen for the AT&T technology profile template is about 4 kilobytes.
Girish, these two are like, they look like configuration. I mean, they don't change too much.
Yeah.
Isn't it?
Sorry?
I mean, these two lines, templates, MIP templates and technology profile templates, they're like static configuration, and they don't change too much. In the startup, you set this configurations, and they, okay.
Yeah. Then there is a technology profile instance, which is stored at the technology, TPID, OLT device ID, and the uniport name. I mean, it is stored at this path. It's an instance of the technology profile. The size is similar. And can this be rebuilt on pod restart? No. This information is created when the first flow that references the TPID, arrives at the adapter. And we do not, currently these flows are not pushed on adapter restart. So this information cannot really be built. And it really requires strong consistency because, flows are processed in such quick succession that we need to have a strongly consistent database. We don't want to, create duplicate TP instances. And if you were to create duplicate TP instances, that would have duplicate resources and, cause all sorts of problems. So this requires a strongly consistent database. So that's all about the template and template instances. Next is the read-write code persisted information. Ken, would you like to discuss this now or later?
I can discuss it now.
Cool.
That's all right.
Should I share my screen or do you want to take control?
No, we can leave it there to switch you back and forth. One question that came to my mind a little bit later was, you can leave it on the read-write code, that's all right, is when we are talking about a pod restart, are we talking about all the vOLTHA components restart, or we are talking about etcd and everything restarts?
Oh, sorry. The pod is really confusing here. Sometimes we say pod as a collection of everything, the vOLTHA stack, all of that. But I really meant, by pod, I meant the container, the specific container that's of interest here. In this case, I was trying to really mean the OpenOLT adapter container pod restart.
Okay, so you're talking about only this, if that specific container goes down.
Yeah.
Oh, okay. So that's interesting. So in the case of the read-write code, there's some data that we store, like the adapter data and the device types. They kind of go together. So then this row and the next row, they're kind of those are the data that we receive on an adapter registration. So can we build that data? Like, let's say we don't save that data in etcd, and the core restarted. If the code just restarted like that, the adapters today will just keep sending messages to the core, and there's no registration, nothing that's happening. And the northbound will come in and will make any request, which is, oh, can you send this message to the adapter? But since the core doesn't have that data, the adapter data, because it has gone from etcd, then all requests will fail. So in that sense, that data needs to be present in the KV store. And here I wrote yes, it can be rebuilt, because I was under the impression that potentially that the adapters also will be restarted as part of that part restart. So if the adapters are not restarted, then we will need to have a separate mechanism where the adapters, when they send any request, they will have to fail a certain number of times, and then maybe retry a register, or to have a mechanism where the core, eventually when it's come back up, it sees a message coming in and tries to say, oh, I don't have that adapter, and trigger a registration. So it's feasible, but it's code has to be changed to make that happen if we want to not save the adapters data. So next one is the device IDs, devices and device ID, because device type and then adapter, they go together.
So quick question, just to make sure I understood correctly. What we need to do if we don't want to persist the adapter data is to get the adapter to re-register to the core after a restart.
Exactly, after a core restart. But
yeah,
given
so they
somehow
need to know that the core went down.
Exactly, right? They will need to know that. But given the amount of data that is stored in the KV store for that, it's very limited because it's just a number of adapters. So that one is like we are not going to really save space, and it's pretty much static data. Once it's written, that's it. So it's I don't really see a reason why we won't keep that, because it's a small set of data.
Yeah, it will be more problematic to rebuild those data than to store a few kilobytes.
Exactly.
That we just read once in a while.
Exactly. So it's my preference is to keep it in the KV store. So the next one is devices. Yeah, go ahead.
Yeah, you're saying that we should persist this data, but
yeah, we should persist the adapter and the device type because it's tiny and doesn't change.
And does it need strong consistency or not?
No, it does not, because we have only one core. So it's the core is the one that is writing the data to the KV store. We have multiple places that reads the data, but there's only one place that writes the data, and it's really writes it at when the system is coming up. So to get in a case of where we need strong consistency, I don't see when we will need that. There is one scenario, and that's a very tiny scenario where, for example, the core has written the adapter data in the KV store, and then there's some request between the core and the adapter, and the adapter, for example, an vOLTHA adapter wants to talk to an ONU adapter. So the adapter will, because we're using this hash ring to figure out like where to send that request. So the vOLTHA adapter will be reading what's from the KV store and then try to send a request. If that data, for example, like it will load everything in its memory and send that request. Suppose it doesn't have all the adapters. Next time you get a request coming in, it will say, oh, I don't have that adapter. So automatically there's logic in the hash ring there to reload everything from the KV store. So that race condition, if you want, that in real life it won't happen, because it's been mitigated by this reload. Does that answer your question?
Yeah. I think.
Okay. So the next one is devices. The devices is I put yes and no there, like in the sense of if we don't process it, then we'll need something from any northbound system to re-trigger the vOLTHA creation. If we don't have that re-trigger coming from the northbound, then that data, nobody's going to tell the core, here's the device data, the vOLTHA and the ONUs. So we need to have something to re-trigger that. if otherwise we'll have to process the data. And it does not require strong consistency.
Why do you say it doesn't require strong consistency? I mean, the device has certain fields that could be, concurrently. I'm not sure if you would try to concurrently modify that data from multiple. Go ahead.
Yeah, so basically, like the devices are limited to a stack and to one core. So we're not talking about multiple core here. We have only one core. So the read-write core is a write-through cache. So all the data are in memory. So it's not it doesn't really read from the KV store per se. It just take whatever is in memory. And inside the core, there's already a bunch of locks around to make sure that those devices are not being addressed by two threads running at the same time. And does that answer your question?
So if the read-write core crashes before, I don't know. I'm just trying to think. So do you think there's no problem if the read-write core crashes before the data is, returned to the HCD? I mean, it has written the data to the in-memory, but it has not, updated that to the KV store, and it just crashes. And there would be no problems then.
And if you scroll down,
I could be wrong. Probably you're the expert here, so.
No, but if you scroll down, I actually wrote a condition where that happened. That could happen. Just scroll a little bit further down. It's under general. I put that under general. Just scroll down here. So this is a scenario that can happen literally on anything, in a sense of, like you said, any request coming in, we're changing anything, and suddenly we are writing to the KV store, the core crash, and the KV store has all data, and we restarted, and those data has not been synced up, so the core load the old data in memory. So that's a potential, but the thing is, like, it's the problem with that is like it's a bigger problem than that, in a sense of we have like here I give an example of an image activation request. If we get a request and into the core, and that request we send back an ACK to the northbound, say, yeah, we got it, and then the core doesn't have time to update any data. Forget the consistency, it just doesn't have time to update any data, and it crashes and comes back up. So we're in this situation where the northbound system thinks it has sent the data, it has sent the request correctly because it got a positive response, but then that process has not gone through because now the core has restarted and doesn't know anything about that request. So that's like it's a bigger issue.
Yeah, got it.
In that sense. So is it like, or do we want to address those cases? I think eventually we'll need to have to find a way to address those, but it's kind of tricky to do those.
Yeah, I mean, it's unrelated to the discussion here, so let's post that for some other discussion. I think.
Yeah. So that's in that sense, in those corner cases where the core is writing data and suddenly the KV store crashes, then the core will have the latest data. But then, no, not the KV store, sorry. The core crashes and then the core comes back up. And then if it reads the data from the KV store, then it will have the potential of reading the old data. That can happen. But it's a very, very tiny window we are talking here.
Mm-hmm.
And it doesn't affect, well, one way of going around that specific cases is if the core restarts, that in any case, it has to do a reconcile, a device reconcile. If it's keeping the data in the KV store. If it doesn't keep the data in the KV store, then it's a non-issue. But if it keeps the data in the KV store, it will have to do a reconcile on that data.
Mm-hmm.
Any other question?
Actually, this corner case is the main problem we're talking on, I think, generally.
I would say yes and no, in the sense of like in the core, for example, like if it's load like all the data, and if it does a reconcile, it can get over it. But if we're talking about in a case where, for example, we're defining a flow ID and sharing it across different threads and trying to get something unique, then it has a bigger impact than what the core, what the impact will be for the core.
Yeah, sure, agree about that. But I mean, the flow ID generation and other things we're using, for example, for resource manager, I mean, we're generally generating them in a single thread, and we generate them on the master node of the database, etc. So we have some mechanisms there in the code. So I think they have some kind of protection for this. But the major problem is, I mean, when we create this flow ID or the data in the module itself, and when we try to push it to the KV store, and something that happens in the KV store on the master, and we cannot persist the data. So it's the difference from the data in the module and the database. I mean, this is the main problem, I think. So, I mean, some of the data, as you said, is less important here. Some say differences are less important. We can say repair them, or we can live with it. For example, we can say issue a ONE reboot and get rid of this problem. Some of these problems, I don't know, but some of them maybe is crucial.
Yeah, I guess we'll have to figure out maybe also the impact of not having that data, of that data being corrupted, and the mitigating factor.
Yeah, that is. I think this is also important. So some of the we are generating a big amount of data, which is some kind of dynamic. I mean, we create this data and use it for a while, then we change it. Like flow IDs, like Gemport IDs, unlock IDs, we're saying that they are important, but we very frequently change them. And if there's some stale data about this data, I mean, we can easily mitigate them by, I don't know, a simple ONU reboot or reprovision of the flow, etc.
Yeah, we'll need to know also the impact, right? Like it's if we do when you reboot, then we are affecting the subscriber, right?
Yeah.
So I guess that's one thing that also maybe needed to add to the document about those the workaround on data corruption, and then we can figure out like which one makes sense to have, and then if we need to, if if the impact is so big that we need strong consistency, then we'll have to go with strong consistency.
That makes sense.
Okay, so the next one is about flows in the core. The flows, they can be recreated from ONOS. The flows, logical device, and all the four there, the logical flows, logical meters, logical ports, all those can be recreated as long as we have access to the device data, at least the OLT data. So if we have access to that, in a sense, either it's being stored in the KV store or the northbound comes in and says, okay, recreate it, then everything is fine. It's everything can be done, can be recreated from that. But if the device data is not there, then obviously none of those, because in order to get the flows, we need to get the logical device. If we don't have the logical device, then there's no logical flows and none of those things present. So it's all started with the device. So if the device is there, then it's good. If there's a way to get the device created, then all this will follow. And when I say all this will follow, I've not tested the code yet, and that's one thing that I want to do. I want to be able to create an image that don't persist flows and logical devices, and see what's the impact if I restart it, and keep, for example, the devices there. So all those components here, they are really like dependent on the device. So if you go further down, so in terms of ports per se, those are the device ports. So those ones, it's really depend on the process of reconciliation. For example, if we keep the devices and then we do the code does a reconcile on those devices, then if the adapters comes in and as part of the reconciliation, it does a ports discovery, then everything can be recreated. If as part of the reconcile, there's no ports discovery, then those data will be lost, and then there's nothing we can do about that. So again, it all comes down to if we have a NOVA system that recreates the OLT, so then everything gets done. Otherwise, that data will need to be persistent, or we find a way to change the adapter code so that during reconciliation, they create the ports as well.
Okay, so thanks, Ken. So in the current state, I mean, as you know, vOLTHA system stands right now, I mean, which of these can be recreated without lockdown system doing some additional things? So
so it would be flows, it would be logical any logical flows, meters, ports.
Okay.
Logical ports, not ports. Logical ports, and again, like I need to try them out because we never had really tried those use cases. So we need to build an image and figure out like how it's working to make sure it's that's the way the entire system is working.
Okay.
So as of now, I'm not sure ONOS will push down the ports again, the logical ports. It will for sure push down meters and flows. I don't think it will push ports to the device because those are generally discovered.
Yeah, exactly.
No. There is no concept of pushing ports. Ports are always something that comes from bottom up. So either from the northbound, meaning flows, meters, groups, any type of configuration that a user of the system can apply is pushed back by ONOS. Anything that the southbound discovers, so links, ports, statistics, devices, anything of that sort is never pushed by ONOS to anything else. Because it assumes that the authority lies in the southbound for those things. It lies in the device. The device knows best what it has in terms of ports, for example, rather than the system up knowing it beforehand. So there is no concept of that.
Yeah, that's correct. So that's why I think like it's if we have devices and ports persisted, then on a core restart, the core should be able to recreate everything, recreate the logical device and the logical ports, and that should in turn trigger all those flows to come down. But I don't think the code works this way today. That's why I want to try it out to make sure it works this way. Otherwise, it's a code change that will be required, because it should be able to recreate everything from just the device ports.
Yeah, but we should also think about the implication. I mean, you have thousands of subscribers and some tens of thousands of flows just coming down in a few seconds. I don't know what impact that has on the system.
Well, that should be pretty much the same impact as the thundering herd, like as when we provision all the subscribers at the same time or adapter restart.
Okay.
That should be a similar load.
I agree with Theo on this one. I think we should be able to handle that already.
Okay. Yeah, I mean, that's good to know.
Yeah, we should try it out.
Okay. Okay. Anything more, or else I will go to the next section. We are short on time.
No, that's it. I'm just going to create an image and try a few things.
Okay. Okay, thanks, Ken. The next one is the OpenVoLTHA adapter persisted information. Yeah, there was some interesting find here. Let me discuss them. So the first item here is the information related to packet indication processing. So when the packet indication arrives from the OLT, the packet indication consists of the PON port and the jump port. Here I refer to packet indication from the PON, not the NNI interface. So it carries the PON port and the jump port. We need the ONU and the UNI information to derive the logical port, which is important for owners to know from which particular port the packet indication has actually arrived. So when the jump port is created for the first time, we create this mapping so that this mapping is useful to derive the ONU UNI information to send the port information northbound for owners. There is no real need to store this information because the agent itself, can send, this additional ONU and UNI ID information. So we can really do away with this data and storing this data on the KB store. The typical size I have seen in AT&T workflow is about 350 bytes. And doing away with this data, we could save about 7.5%. When I say 7.5%, this is a percentage of the total data that is stored by the OpenVoLTHA adapter. Now, it doesn't account for others like templates or rewrite code information. There is a lot of other low-level details here. You could go through that when you have time. The next one is the information related. We store information related to the flow ID references for a given jump port ID. This was useful. So basically, when the flow IDs, when the flows are removed, we would want to clear the gem port when the last flow that references this gem port is actually removed. So this information is useful in that case. We cannot really do away with this data, but we could store the data in a slightly different format so that we don't have to query a large bulk of data. So it would need some reorg on the way that we store this data. And that would lead us to transact smaller amount of data per transaction. The next one is we store the NNI interface IDs that are associated with the vOLTHA device ID. This information was actually useful for processing the multicast flow groups, as this information is actually missing in the flow group message. However, this information can also be queried via the get device port API on the core proxy interface. So we need not really store this information. And this information is typically about 85 bytes. And doing away with this, we could save about 2% of the data. 2%, we could free up about 2% of space. The next one is related, is the data related to packet out processing. So when the packet in first arrives from the RG/ONU, it carries, the PON ONU. We store the information for that PON ONU UNI and VLAN PCP. We store the gem port ID associated with that, packet in. And when ONOS does a packet out for that subscriber on a particular VLAN PCP, we need to know the gem port ID on which we need to packet out. Because ONOS doesn't send this information, we should have built this information already when the packet in first arrived from the ONU. So this information was useful for that. But we really need not persist this information. The adapter could just cache this information. And if the adapter were to restart, although this information is lost, we expect that the application at the RG would try to send the packet again, like EAPOL or DHCP. So this information is actually rebuilt, and there is no real need to persist this information on the KV store. And I have typically seen, so with AT&T workflow, this occupies about 210 bytes of data, and doing away with this would save about 4.5% of the space.
Girish, a question here.
Yes.
Is that also applicable, for the multicast? You say when during the adapter restart, we can regenerate this data because the client RG will send a DHCP package or EAPOL package, etc. But if this, for the services that client doesn't send something at least frequently, but the traffic, say, is coming from the upstream. So in this case, can we generate it or not? I think there is a gap there in multicast, for example. We may lose something.
Okay, yeah, I have.
I'm not sure. I'm only thinking loudly,
Yeah, I share your concern. I wasn't completely sure here. Actually, I wanted to solicit feedback on this one. So in case of I believe you mean the IGMP joins. Are they recent? Is that what you mean?
Yes. If we need this data also for say data path.
Data.
Yeah, and multicast traffic.
Uh-huh.
Do we need this data for generating on data path?
No. This is just for packet out processing. The multicast I believe you're talking about sending IGMP queries from ONOS.
Yes.
Yeah, I mean, yeah, I think so. We probably might need, I wasn't completely sure. So the IGMP join would come on a particular gem port and we build this information. And when ONOS has to send out the IGMP queries, we have to send out the packet on the same gem port again. If the RG isn't sending the IGMP joins again, we probably, might not have this information at all. So yeah, you're probably right there. This might work for EAPOL or DHCP, but not for the IGMP use case. So yeah, you're right. You're probably right.
Okay, thank you.
I have made a note of this.
Also, there's the IGMP general query case, which is triggered by ONOS. So ONOS periodically sends IGMP query to the ONUs.
Mm-hmm.
So if we need to gem port IDs, then we cannot read that information when the general query is sent.
Yeah, that's what I was saying. So the IGMP queries might not find the gem port if that actually restarts. Yeah, you're right. Okay. The next one is really interesting. So we are storing the OLT device flow information on the HCD as of today. I mean, this was needed in the legacy scenario where we were managing the flow ID and flow ID management was and device flow ID management was entirely under the purview of the OpenOLT adapter. Now it has actually moved completely to the agent, and this data really finds no much relevance as of today. So we could completely do away with storing the device flow ID, device flow information on the HCD. For AT&T use case, just with one subscriber, I was seeing like 2,800 bytes of data, and this accounted for about 60.5% of the total data. And doing away with this, yeah, would save the entire thing. And the next one was storing the flow IDs that are associated per subscriber. We were actually using this information to block duplicate, sending out duplicate flows towards the OLT device. The read-write core actually carries a flow ID, and for some reason, if the northbound system would send the same flow again, we would block this. I mean, we would check against the KV store if the flow ID already exists, and then block that flow. I have never seen, I have rarely seen actually a duplicate flow ID actually coming to the adapter. And if the adapter were to really send this flow again to the OLT device would actually just ignore it. I really don't see much use of storing this data and all the processing that is associated with it. So I believe we can do away with this data as well. About 3.5% saved.
Girish, you mentioned that duplicate ID coming from the core. It's the flow ID is meant to be unique. It's based on some of the fields from the flows. So,
sorry.
So you have seen cases where it is duplicated?
Sorry, let me correct my statement. I didn't say duplicate flow IDs. I meant the same flow arriving from the entire flow arriving at the adapter again.
Ah, okay.
But thinking of it now, I mean, if the read-write core were to restart and the read-write core not persisting the flows, then we would have all these flows dumping on the adapter in bulk, and all these would be sent to device at once. I'm not really sure we would want to do that, block these flows at the adapter. Yeah, but that's something that we need to think about.
Okay, so that's quite interesting, because if that's going to cause some problem, then we need to find a way of maybe preserving some of the flows in the core. Maybe the device flows, but not the logical flows. Maybe.
Mm-hmm. Also, this data isn't quite significant, so the adapter also could just persist the flow IDs, not the entire flow, and it could. Yeah, this would need further discussion.
Oh, okay, thanks.
The next item is the TPID, the list of TPIDs that are associated for a given PON ONU uni. This information cannot really be rebuilt on the adapter restart, and this information is useful for TP instance management at the adapter. Yeah, I mean, this could be rebuilt if all the flows are pushed again, but on adapter restart, but that's not the case really today. So we really need to persist this information. And this would require strong consistency, given that flows are processed in quick succession, and we need to have strongly consistent data on the database. And the last one is the meter information that is associated for a given PON ONU uni TP ID and direction. We are currently storing the in a bulky meter infrastructure. We really don't need to do that. All we need is a meter ID for the given PON ONU uni TP ID and direction. So the bulky structure is about 560 bytes, and it could go all the way down to 215 bytes with just storing the meter ID, and that would save about 7.5% space on the DB. There are some with the original proposal that I had. I mean, we could save about 85%. We could free up about 85% of the space that OpenVoLTHA adapter was occupying on the DB. But given that we have some concerns about this item and this one, 3.5 plus 4.5, that's about 8%. We could still say about close to 75% of the space on the DB. I mean, that's still good.
I would say that's still very good. I mean, even if we talk 70% and make it 70, it's still a lot in respect to the numbers that we are having right now. And that could probably enable us to have a much better performance from etcd itself, because the read and the write of the data would be much lower in terms both of numbers and thus faster, because the numbers itself or the data itself is lower. So I don't know about the rest of the folks here, but my proposal would be to go ahead with some of these implementations, some of these simplifications and implementation, Girish, if you can, and also if you can in the core. Meaning start taking a look at firstly the highest elements, especially like, for example, the OLT adapter, that the one that was occupying about 60%. That is, I think, the first one that we could work on. So I'm not sure what the rest of the TST thinks, but I think this exercise is worth doing in the upcoming week or so, 1 or 2 weeks, starting with the most, the items that occupy the most of the storage. And we can then start testing this and see what the outcome is, and then make a further decision around the TCD, Redis, persistency, etc. This is a good optimization independently of the storage that we use. So it's a good find, both for, and thanks a lot, both Ken and Girish for this. And it's a good thing that we could and should optimize. But what other people think?
Yeah, I agree with that. It's I think at least the low-hanging fruits, we should be able to tackle that. Like on the core side, the one that takes the most space are the flows. So that's something that can be tackled. And just like Girish said, like if there's too much flows being sent to the adapters, and if that causes a problem, then we can just revert that change. But it's I think something that is worth exploring, because like you said, irrespective of the KV store or structure that we choose for DB, this optimization is needed.
Right.
I agree that this optimization is a great thing to do. Yeah, it needed, but I think we still have the same problem about the KV store. I mean, we're still writing devices and a lot of data, which is changing very frequently during the device restarts or electric power off cases, etc. So etcd is not configured to handle the frequently changed data. It keeps revisions of data. It keeps each change of the data in memory and on disk. So it's a bit heavy process. So we still have these problems, I think. We also have to deal with that in parallel, you know.
Yeah, I agree. But this one would be a good first step.
Yeah, of course, this is good,
yeah.
but
yeah, and eventually we need to move to a transactional database, because if it's like you said, if the level of updates that we are doing that doesn't decrease, then with something like etcd that just create revisions for everything that it's and kept those revisions, then long term that's not good.
Yes, that's good. And it's doing something here is important, perhaps, for the context of vOLTHA 2.8, because and we think that we should do it LTS. And I don't know if we should change etcd in this time frame or not, because going with etcd for an LTS version may not be good.
So to be honest, I don't want to open the discussion now also because we are outside of the time, but something to keep in mind is that if we achieve such a lower percentage of storage, we should not encounter the same issues around compaction and occupation of space and things like that we had in the past with the TCD. So the number of gigabytes that a TCD would use would go down. And that would enable us to extend the time where a TCD would need a compaction and need a defrag. Because right now we're talking gigabytes, a lot of gigabytes.
A lot of gigabytes for only a few thousand users, not for 100,000 users, you know.
Indeed. The issue is that is unfortunately not part of our testing, meaning that the scale numbers we have not increased up to that. What the scale numbers we have increased are 10,240. So that is what we are trying to hit. I know there are other numbers that you guys are looking at, but that needs to be brought into ONF as a scale number before we can start working towards it. As I said, I don't want to open the discussion right now on that, but my take on this is, and we can discuss it next time, if we achieve scale with persistency on a TCD, thanks to the optimizations that Ken and Girish will do, we will release 2.8 with a TCD. That is my take. I'm not saying it's what we are going to do for sure, but given the request that the 2.8 has, I think that if we achieve the scale with the TCD and persistency on, we will live with that. Having said that, food for thought next time, because I think we're at the top of the hour and it's best that we conclude the meeting today. I also know that there is some OpenONU adaptation that needs to be discussed. So I'll reschedule the topic for next time right away, so I don't forget to mention this discussion that me and Mahir just had. And let's think about this in the next few days. Happy to have a discussion over Slack, over an email with anybody who's interested. Girish and Ken, if you want to start the work, go ahead, please. And let's continue on that. So thanks a lot, everybody.
Bye.
Thanks.
Thank you. Bye-bye.